Now we're going to do 5.9, systems of linear equations, solutions by addition. So this is going to be a way that when you're looking at these two equations, your goal is to multiply or divide either or both equation by numbers so that when you add the two equations together, either your x's go away or your y's go away. In other words, if the coefficient of x is negative 3x, we want the coefficient of this x to be positive 3x. And then when you add negative 3 and positive 3, they disappear. So this one is has different values for x's and for y's. I mean, not values, I'm sorry, coefficients. So if I just look at this, and usually if there, like I said before for the last video, if there's not an obvious one that's going to be super easy, like if I double the x's, then they'll be opposites, then just pick the first equation, the first variable and get rid of them. So for this, for example, if I multiply that top equation by negative 5 and the bottom equation by 3, if I do that, my x's will be positive 15x and negative 15x, and they will cancel each other out when I add them together. So you will get better at picking these numbers when you spend some time practicing here. But remember that if you like that substitution method that we did in the last section, you really understand it, you can solve all of these that way too if you want. But I'm going to solve them all with addition because unless there's one that is already set up for substitution, and I'll point that out. But I find that addition is lovely when you get used to it and you understand how to do it. So I'm going to distribute here, negative 5 times negative 3, 15x. Negative 5 times positive 3 is negative 15y. And negative 9 times negative 5 is positive 45. Now I'm going to do this guy times 3, so he becomes negative 15x plus 15y equals 45. So I'm going to add these two together. So my x's cancel each other out, but in this case, so do my y's. So I end up with 0 plus 0 equals 90, or 0 equals 90. That's always false. So that's one of those special situations where there's no solution. So we'll go back over here, say nope, no solution to that one. How about the next one? All right. Oh gosh. Okay. So if I look at this and I can't do anything to 4 to make it 10, I can't do anything to 2 to make it 5, so I'm going to have to multiply both equations by something. And I'm going to pick the y's to focus on just because 2 and 5 are smaller numbers than 4 and 10, and I like to keep my life easy. So I'm going to multiply this guy by negative 5 and this guy by positive 2, because that'll give me negative 10y and that'll give me positive 10y. So when I do that, I have negative 20x minus 10y equals positive 100. And I have 2 times 10 is 20x. This one might be a funny one again. Plus 10y equals negative 100. This one might always be true, though. 2 times 50, yep. So 20x minus 20x is nothing. 10y minus 10y is nothing. 100 minus 100 is nothing. So the difference for this one, it's weird again, but it's always true. So don't just start seeing zeros and freaking out and thinking that your answer is either 0, 0, or always true or always false. So this one, 0 equals 0, that's always true. So it's infinitely many solutions. Hopefully this one will actually be different. Let's just try it and see. All right, what I noticed right away here is if you look at the y's, if I left that top equation alone and just multiplied that bottom equation by negative 2, then my y's would cancel out. So that's what I'm going to do. This guy times negative 2. So my top guy stays the same. So I'm going to rewrite him. But my bottom guy I'm doing times -2, so that becomes positive 12x minus 4y, positive 44. So now when I add these, my y's go away, and I get 16x equals 44 minus 22, 28, 24, 16. Divide by 16, so x is 1. All right, so now I just need to substitute x equals 1 into either one of those two equations. And just to make my life simpler so I just don't ever have to think about it, I just always plug it into the first one. So 4 times 1 plus 4 times y equals -28. 4 plus 4y, -28, minus 4, minus 4, 4y is -32. I'm sorry that this handwriting is so messy. Y is -8. So again, I did that super fast. I can do it fast. You can't probably do it as fast as I can. That's fine. Pause, watch again, whatever you need to do. So 1, -8. And also sometimes when I go that fast, I make mistakes. So that's not good. Okie dokie. Okay, so here's a great example. This one is already just totally set up for substitution. So why on earth would you not use substitution for this? So even though it says by addition, I'm gonna say, well, you've already, because of this, you've already solved for y in terms of x. So I'm just gonna substitute that guy into here. Why would I work any harder than you want me to? Or than I should. So -3x plus 12 equals -3x minus 21. Add 3x to both sides, and look what happens. They're gone. And I have a statement that says 12 equals -21. Well, that's false, so there's no solution. All right, this one is also set up for substitution, so I'm going to do it that way. Because if I just divide that first equation by 3, I get y equals x plus 10. Super easy. Substitute that into here. 4x plus 4 times x plus 10 equals 16. 4x plus 4x plus 40. 4x and 4x is 8x. Take away 40 from both sides. 16 minus 40, -24. So x is -3. Plug that into here. -3 plus 10 is 7. -3, 7. All right. This one is trying to get you ready for the next couple sections, which will be word problems. They call them applications, but they don't give you the equations. And so you might want to take the time to read through this and understand how they set up these two equations, because the next two sections you're going to have to set up the equations yourself. And you're always looking for two equations, and basically you're going to let x be one of the things they're looking for and y be the other thing they're looking for, and then figure out what your two equations are going to look like. And this one talks about x is time for travel for the first truck and y is time for the second truck. And it says they travel for the same time. So your first equation is that the travel time for the first truck equals the travel time for the second truck. So there's your x equals y. And then it's talking about distance equals rate times time. So the travel time times the rate for this one is going to give you the distance for this one, and the travel time times the rate for the other one is the distance, and how long until they're 351 miles apart means the distance one truck went plus the distance the other truck went has to be 351. So I'll do more slower explanations of those kind of problems in the next videos. But for now, we've got this, and this is also super easy. It's already set up for substitution. They tell me x equals y, so I'm just going to plug in x for y or y for x, doesn't matter, because they're the same. So 60 and 57 is 117, 57. 117x equals 351. So x is 351 divided by 117, which is 3. So if x is 3, so is y. All right. All right. Again, they've already set me up for substitution because y equals something with x in it. So I'm not going to do this one because I would do substitution, but I would like to do another addition problem for you so that you can see another one. This one also set up for substitution because x equals y plus something. So you would do substitution for that. Here's one. You can do this two ways. You can keep the decimals inside your problem, or you can multiply by whatever power of 10 you need for them to go away. So let's see. That's up to you. If you multiply everything by 10, you notice this each decimal will move one place to the right. So that would be negative 12x plus 3y equals 162. This one would be 36x minus 9y equals negative 446. So that's if I multiplied everything by 10. All right, now I look at my y's and I have a plus 3 and a minus 9. So if I did this guy times 3, then my y's would cancel. Turns out so would my x's. So let's see what happens. So this becomes the first equation, negative 36x plus 9y equals 486. And then the other one stays the same, 36x minus 9y equals negative 446. So this left side is 0, right? Because gone, gone. And this becomes 40. So that's a positive. That is a false statement, so there's no solution. Everybody loves fractions, so I'll do this one. I have denominators of 3 and 4 and 4 and 16. So if I multiply this first equation by the LCD of 3 and 4, which is 12, and multiply the second equation by the LCD of 4 and 16, which is 16, that will get rid of my fractions. So 12 divided by 3 is 4, so I'll have negative 4x plus 3y equals negative 15. 12 divided by 4 is 3 times negative 5, negative 15. 16 divided by 4 is 4, so this becomes 4x minus 3y equals positive 15. So now when I add them, those cancel, so I have 0 over here. Well, those cancel also. So that's always true. So that's infinitely many solutions. This one should not be too hard for you. If I just double everything in the first equation, my fractions will go away. Negative 2x minus 1y equals negative 1. My other one was 5x plus 4y equals 23. So I can make my y's have opposite coefficients if I multiply that first one by 4. So if I do that, I'll have negative 8x minus 4y equals negative 4. And my bottom one is 5x plus 4y equals 23. So add, those are gone. Negative 8 and 5 is negative 3x equals, that was a negative 4. 23 minus 4 is 19. So I'm going to get a fraction of negative 19 over 3 for my x. That's a weird enough answer that I might take a second to look back and make sure I did this right. But it looks like I did, negative 3x. This is positive 23. Yep. So I'm going to go with that. And then I'm just going to plug that in back into either